Hello, good afternoon, sir.
Yes, good afternoon, Rasaji. Yes, start quickly. Let me start. Introduce yourself.
Okay, yeah, my name is Rashid Ahmed, and I belongs to UP district Saharanpur. I have completed my class 12th and class 10th from the Saharanpur, and I have completed my graduation from Delhi University in chemistry honors in 2016, and then my masters from Jamia Millia Islamia in 2018 in chemistry. Then I started working as a chemistry faculty in VMC. Then I left my job. I started uh, completing my B.Ed from Kurukshetra University. In 2021, I have completed my B.Ed. Now I am currently working here in Rewari, Haryana as a chemistry teacher. My hobby is playing cricket, and uh, teaching is my passion. So I find myself eligible for this particular job. Thank you.
Good. Are you qualified CSIR net and GATE?
No, sir. Actually, I haven't filled the form for CSIR and net yet.
Yes, your M.Sc 2018.
Yeah. Actually, I have when I completed my MSc, I started working as a chemistry teacher, so I haven't thought about the CSIR net or GET. And actually, I was having the DST's Inspire Scholarship, through which we can also get the JRF, but I haven't tried for the PhD.
Yes. What is the difference between CSIR and GATE?
CSIR
And GATE.
and GATE.
Yes.
Okay. So, sir, by like in case of CSIR net, if we pass this particular exam, so after passing this exam, we get the scholarship like JRF, and if we pass the CSIR net exam only, so we are eligible for the uh, post of assistant professor in the university. We can teach, and after passing the GATE exam, we are eligible for the admission in IITs. And in case of some PSUs, also we can directly go.
What do you think about Indian research?
Indian research.
Yes.
Yeah, okay. So, according to me, like if we, when I was studying in the Jamia Millia Islamia in 2018, so what I have observed is the research work is going very good in the universities. But the problem is in the main or the main universities like IITs or uh, like Tata Institute of Fundamental Research or CSIR labs. So in these particular universities, the research level is very high. But in case of like we talk about the state level colleges, the research work is not that particularly good in that particular colleges. So uh, what I think is we need to focus on that colleges also. If we compare ourselves with the like universities in the USA, Germany, etc.
Yes. Why will you become a KVS PGT teacher?
Yeah, sir. To become a teacher, when I completed my masters, and I was working in Vidya Mandir classes as a chemistry teacher. I find that this is the right profession that I was working for. So I started working for to become a teacher, and I thought I should complete my B.Ed if I want a profession like becoming a teacher. So I started my B.Ed, and then after completion of my B.Ed, I thought like if I want to be a teacher, so I should work in a particular uh, good institute like KVS. So I opted for the KVS, and I filled this particular form for the KVS PGT chemistry. because it's a good institution or the good area to work as a chemistry teacher and to enhance my knowledge in that particular field.
Yes, good. Can you explain National Education Policy 2020 in India? Why did it implement in Indian education system?
Okay, so basically, if we talk about the education policies, so there are majorly three education policies. The first one is in 1968 and 1986, and the latest one is 2020 NEP. So in the NEP, there are lots of problems that have been addressed by the government of India, and particularly what are the fascinating features of NEP is in NEP there are four stages. The first one is foundational stage, and the second one is preparatory stage. In the foundational stage, what we have observed what they are offering is in foundational stage, the students will all the child will go into the playing school like Anganwadi, Balwatika, etc. So where they will learn something about their culture and the ethnicity of that particular area. So it will be helpful for the child to adopt these particular things in the childhood. And after this period like foundational state, which is of 5 year, from third to 6 year, the child move towards the preparatory stage, and this preparatory stage is of 3 years. In that particular stage, the child is will try to learn something, or the examination will start from this particular stage. In the earlier stage there were no examination, and the child will learn from the experiential learning. And in the preparatory stage, the child will learn the concepts in its mother tongue or the native language. So it will be helpful to understand the complex things in the simpler manner. And if we talk about the another stage of this particular NEP, the third stage is of foundational stage and preparatory stage, and the third stage is uh, sorry, I'm not getting the name of that particular stage, but in that particular stage, the child move from the class 6 to 8, and in that stage, the child will learn the vocational courses, which will be helpful in the future for the child, and like coding and other activities, science, arts, etc. He will learn. And the more important feature of that particular stage is the child will learn an Indian language. It could be Malayalam or Odia language, whatever they want to learn, they can easily learn. And after that particular stage, a secondary stage will come. In this stage, it's of 4 year. The child move from the ninth to class 12th. And in this stage, the new thing is the examination will be of semester wise. So there will not be annual examination. And the more benefit of this change in examination is child will not be like free in a whole year, and he need to study hard to pass in the examination. And the more important thing for that particular stage is there is no stream type things. So a child who is studying in the physics, chemistry, so he can easily opt another subject like geography, history, etc. in that particular stage. And one more important thing for that particular stage is the child can also learn a foreign language. So these all things are fascinating. Which the more important thing of NEP, what I think is it focus on the 21st century skills, and these are very important to each and every student. 21st century skills like communication, creativity, leadership, etc.
Yes, good. How many stage in any national education policy?
How many
Stage.
stages? Yeah, there are four stages.
Yes.
The
5
first one
plus.
is foundational stage, then the middle stage, and I'm forgetting the name of the third stage, and the last one is secondary stage.
Yes. 5 plus 3 plus 3 plus 4. 4
Yes,
stage.
sir. The first one is 5 years, then 3 years, then 3 year, and the fourth year. In particularly 5 year, the first 3 years will be in the Anganwadi Vatika, and the next 2 years in the first and second class.
Yes. Good. You did pass 10, 12th and 10, 12th from UP, yes?
Yes, sir.
BSc, MSc from Delhi, means
Yes, sir.
BSc Delhi University, MSc Jamia Islamia.
Yes, sir.
Yes, what is the difference between UP education system and Delhi education system? What's your opinion?
Okay, so first of all, I've completed my class 10th and 12th from UP board, and as far as I talk about the Delhi education system, I haven't go into the school. I just completed my graduation and masters from Delhi. But what I see is in the Delhi, the like government schools are more good in terms of education, in terms of infrastructure. But if we talk about the schools in the UP, they are far behind these schools due to like lack of like implementation of the policies in the grassroots level, etc.
Yes, good. What is the difference between NBS and KVS education system? And when did it stabilize?
Okay, so if we talk about the NVS and KVS, the KVS is basically earlier KVS, there was 20 central school, which now is being now is called the KVS, KVS Kendriya Vidyalaya Sangathan. In 1963, it is started, Kendriya Vidyalaya Sangathan, and now there are 1200 plus schools, which is like all over the India. And if we talk, they are basically for the central government employees, and the students they are studying there in the KVS are the like childs of those working persons. If we talk about the NVS, NVS is basically for the rural areas. Like what is the what was the main motto between the establishment of the NVS was the education should be like easily accessible to the areas like remote areas or the villagers. They can easily go into the school and learn something about from there. It has been started by the Rajiv Gandhi in like I'm not able to recall the particular year. So
Yes, good. Yes, good. Today topic is your
you were
last
saying chemical bonding.
yes, yes.
Okay.
Can you teach on whiteboard?
Okay.
Yes.
Is it visible to you, sir?
Yes, sir. Yes.
Okay, so today we are going to start a very important chapter of inorganic chemistry, that is chemical bonding. Chemical bonding. So in this particular chapter, what we need to learn is, we'll summarize in a brief. The first part will be what is chemical bond, what is chemical bond, and then we'll learn about how the chemical bond is formed, how the chemical bond is formed. Next, we'll learn about a more important concept, that is why chemical bond is formed, why chemical bond is formed. After these two topics, we'll learn about the theories related with covalent bond. There are basically two types of bond, covalent bond and ionic bond, which majorly we'll discuss in this particular chapter. So theories related to covalent bond are, the first one is Lewis theory, or we can say Lewis octet rule. Lewis octet rule. And the second is VBT, valence bond theory. And in VBT, we'll also discuss hybridization. After completion of hybridization and the limitation of VBT, we'll discuss VSEPR theory, valence shell electron pair repulsion theory. After completing of these two theory, we'll move towards the another most important theory, or the latest theory, that is molecular orbital theory. After completion these theory, we'll be in the position to explain what is chemical bond and how it form between the two atoms. Okay. Now, then we will discuss about the ionic bond, favorable conditions for the formation of ionic bond, and how does the ionic bond is formed. Then we'll discuss the lattice energy and hydration energy, then Born-Haber cycle, and then the most important rule, it is called Pajan's rule. After completing these, the third last part is the bond parameters. Bond parameters. So in bond parameters, we'll discuss something about the bond length, bond energy, bond order, etc. Okay, so this is the basic what we have to learn in this particular chapter. Now, we'll start from the types of bond. Now we'll start from the types of bond. Okay, so the first question is, what is chemical bond? What is chemical bond? So chemical bond, basically the attraction force which holds between the two atoms, or in case of weak forces, it is the attraction force between the molecules. So it is called the chemical bond. The attraction force between the two atoms is called chemical bond. How does this chemical bond is formed? It is the result of the redistribution of electronic cloud between the two atoms. Redistribution of the electron cloud between two atoms. Okay, so now we'll discuss about the types of chemical bond. So there are basically two types of chemical bond. The first one is interatomic bonds, interatomic bonds, and the second one is intermolecular bonds. Intermolecular bonds. So in case of interatomic bonds, the first one is covalent bond. Covalent bond. The second one is ionic bond, and the third one is coordinate bond. It is the special example of covalent bond. And the last one is metallic bond. Metallic bond. Okay, now if we talk about the intermolecular bonds, these are of two types. The first one is hydrogen bond. The second one is van der Waals force. It is of also two types. The first one is ion and in molecules. It can be between the ions and molecule. The first one is ion dipole interaction. Ion dipole interaction. And the second one is ion induced dipole. And if we talk about the another type is that will be molecule interaction. The first one is which acts between the polar molecule and polar molecule. It is called dipole interaction. Dipole interaction or Keystone forces. Keystone forces. If we talk about the polar molecule and non-polar molecule, it is called dipole induced dipole force. Dipole induced dipole force, and it is also called Debye forces. Debye forces. The last one is between the non-polar molecules and the non-polar molecules. It is called instantaneous induced dipole induced interaction. Instantaneous dipole induced dipole interaction, or basically we call this particular force is van der Waals force or dispersion forces. But in NCERT, it is mentioned that these type of dispersion forces also exist in about two examples also. So we can say polar molecule, dipole, and dipole induced dipole is also an example of van der Waals forces. So these are the types of force. These are the strong force, and these are the weak forces. These are the weak forces. These are the weak forces. So in today's class, we learned about the one theory that is very important, and it is called MOT, molecular orbital theory. It is called molecular orbital theory. This theory explains the bond formation between the atoms. How does the molecule is formed? So there were some limitations of VBT, valence bond theory. So the first limitation of valence bond theory was, according to VBT, O2 is a diamagnetic molecule. O2 is a diamagnetic molecule. So if we take the example of oxygen, here the lone pairs are present. So if we count the number of electrons, it would be even. So this particular species is diamagnetic in nature according to VBT. But when we see the liquefied oxygen is present in like magnetic field. So it shows the magnetic behavior of paramagnetism. So this particular behavior was explained by MOT. According to molecular orbital theory, we can explain the magnetic behavior of oxygen. So this was the limitation of VBT, and we can easily explain using the MOT. The another limitation of VBT was it could not explain the existence of the molecule, existence of molecules. So according to VBT, like if we try to understand which molecule will exist or which molecule will not exist, so we can't say anything about that. But in case of MOT, we can tell the existence of the molecule. It explains this particular phenomena. And if we talk about another limitation of VBT, it could not explain the fractional bond order. Fractional bond order. But MOT can explain the fractional bond order. Just wait a second. Sorry. So MOT explain the fractional bond order. So these are the limitations of VBT, which easily explained by the molecular orbital theory. So according to MOT, there are some postulates. The first postulate of MOT is, as the atomic orbitals belongs to atoms, in the similar way molecular orbitals belongs to molecules. When two atomic orbitals combines, they form two molecular orbital. So here I want to differentiate between the hybridization and the molecular orbital formation. There is a confusion between the student. When the hybridization take place, the atomic orbital combines to form. It is also the mixing of atomic orbital, but in case of hybridization, new atomic orbitals forms. Two new atomic orbitals is formed. But in case of molecular orbital theory, when two atomic orbitals combines, they form two molecular orbitals. So this is the basic difference between molecular orbitals and hybridization. Okay, so when two atomic orbitals combine, they form two molecular orbitals. These are of two types. The first one is bonding molecular orbital, and the second one is anti-bonding molecular orbitals. The formation of these molecular orbitals are the result of LCAO method, that is linear combination of atomic orbitals. Linear combination of atomic orbitals. The bonding molecular orbitals are more stable and having low energy compared to atomic orbitals, parent atomic orbitals. But in case of ABMO, it is having high energy and less stability, and high energy compared to parent atomic orbitals. So if we take the example of, like, we are having the first atomic orbital A and the another atomic orbital B. So the wave function of this particular orbital A can be expressed like this, and the wave function of the another orbital is like this. So if we take, like, it is a psi A and this one is psi B. Okay. When these two atomic orbitals combines, they can be combined in two different ways. The first one is, these are the waves of atomic orbital. This one is first wave and this one is second wave. When they combine, this combination can be constructive interference, and it could be destructive interference. In case of constructive interference, these two molecular orbitals, psi A plus psi B, they combine and they form the electron density or the amplitude of this particular wave will increase like this. But in case of destructive interference, the amplitude of this particular wave will decrease. So this is the formation of BMO, bonding molecular orbital, or this is the formation of ABMO. Like if we take the example of 1s orbital of hydrogen, when it combines with another 1s orbital of hydrogen, so the wave function would be like this. This is the wave function of 1s orbital. This is the graph between psi versus r, psi versus r. When the constructive interference will take place, the electron density increase between the two nucleus or the two nuclei. It would be something like this. So this represents the psi square versus r graph. So here it is called constructive interference. But if we take the example of destructive interference, then the 1s orbital of hydrogen like this will combine with another orbital of hydrogen like this. So the electron density between the two nucleus will decrease. This is the graph of psi square versus r. So after discussing about the BMO and ABMO, formation of ABMO take place like the above graph and the BMO. We can say that if atomic orbital is this particular energy level, this is the energy, then the energy of bonding molecular orbital will be sorry, just okay. So the energy of bonding molecular orbital will be like this, and the energy of anti-bonding molecular orbital will be this. It is compared to higher than atomic orbital, and it is lower compared to atomic orbital. Now we'll discuss about the combination of atomic orbitals, combinations of atomic orbitals. So if like we are having the 1s orbital here, the positive sign represent the sign of wave function like this. If the constructive interference will take place, then the electron density will increase between the two nucleus, and it is the example of sigma star 1s. I want to tell you the one more important thing is when we fill the electrons in bonding molecular, or we can say the molecular orbitals, they follow the simple rules of like Hund's rules of maximum multiplicity, Pauli's exclusion principle, Aufbau rule. But here we cannot determine the energy by using n plus L rule. Experimentally, we can find the energy of the particular molecular orbitals. Another important thing that we need to discuss here is in case of molecular orbital theory, when we take the example of sigma star 1s, so there is no node between the on the axis, like we are having node 0. What is the node? Node is the area, or we can say the plane. Here we will discuss about the plane. So node is the plane where the probability of finding the electron is 0, where psi will be 0. The probability of finding the electron is 0. That particular plane is called node. And if we talk about the sigma star 1s, so there is no node in this. If we take the example of sigma, here we are taking the example of 1s and 1s combination. If the bonding molecular orbital is formed, BMO, then it is called sigma 1s. And if we take the example of 1s and 1s, and their destructive interference is taking place, here constructive interference, then the electron density will decrease between the two nucleus, and the electron density will decrease between the two nucleus. They will repel each other, and here we will find a one nodal plane, or we can say node. So it is the example of sigma star 1s. If we take the another example of like combination of combination of p orbitals. So as we know, we are taking the internuclear axis at the z-axis by default. So it is the z-axis. So there are of three types of p orbital. The first one is px, second one is py, and the last one is pz. So two types of the combination can take place between the p orbitals. The first one is the formation of sigma molecular orbital. So if we take the example of sigma molecular orbital, like we are having the pz atomic orbital like this, and another pz atomic orbital like this. If these two atomic orbital combine constructively, then the electron density between the region increases, and it will be like this. Okay. Yeah. So this is the example of sigma 2pz. If we take the example of the destructive interference, then the electron density between the nucleus will decrease like this, and there will be a nodal plane, and there will be a nodal plane like this, and it is the example of sigma star 2pz. Here we can also discuss the Girard and un-Girard molecular orbitals. Okay, so before going to that, we will discuss like the formation of pi molecular orbital. How does the pi molecular orbital is formed? If we are having px or py, px or pymo like this, here the lobe of the p orbital is different, like negative sign is here and positive sign is here, and in this case the positive is here and the negative here when the destructive interference is taking place.
Good, good, good. Yes, good explain. आपने अच्छा एक्सप्लेन किया है. बेसिक टू टीचिंग, बेसिक टू आई. यस, केमिकल बॉन्डिंग. यस, अच्छा है. अब नेक्स्ट डे हम डिस्कस करेंगे नेक्स्ट टॉपिक की सॉल्यूशन.
यस सर.
यस, गुड. बाकी आपका जो रेस्ट पार्ट था, क्योंकि 30 मार्क्स का है इंट्रो, तो उस पर काम किया है आपने थोड़ा और. अब हम उसको थोड़ा और वर्क करेंगे कि क्वेश्चन में ज़्यादा करूँगा. तो थोड़ा उनके हेडक्वार्टर, केबीएस, एनबीएस, लोगो क्या है उनका, और मोटो क्या है, उनका चेयरमैन कौन है, ये सारी चीज़ें आप स्टडी कीजिए, है ना. नेक्स्ट डे हम इन पे ज़्यादा थोड़ा वर्क करेंगे, एनबीएस केबीएस, क्योंकि वो भी 30 मार्क्स का है.